So suppose, as another example, the temperature at the point x comma y is given by f of x comma y equals x to the y plus 10x. Then how does the temperature change instantaneously by starting at the point 3 comma 4 and moving to the northwest? Well, northwest means, 1 unit left, 1 unit up, right? So I would naturally think of the vector that the direction we'd need to travel is -1 comma 1, although that is not a unit vector. So we normalize it. And since the vector v has magnitude root 2, we need to divide by root 2. And so the direction, so the vector that points in the correct direction but is a unit vector is going to be -1 over root 2, comma 1 over root 2. And then we can compute the gradient of this function. Just did that here. We'll avoid explaining all the computation there. And then we're just going to plug in 3, 4. So instead of the vertical bar notation and a subscript 3, 4, this time around I just wrote it as 3 comma 4 in parentheses. It's almost like we're treating this vector thingy here like a function, and we're evaluating at 3, 4. So there are various notations, but I think you'll get used to this just fine. So plugged in here. And then to compute the directional derivative now is to dot this vector here, the 4 times 3 cubed plus 10, comma 3 to the 4th ln 3 vector, dot that with the -1 over root 2 comma 1 over root 2 vector. And so I didn't bother writing so many steps here. That dot product is this number right there. Okay, an interpretation of what's going on is if you start at the point 3 comma 4 and you start moving towards the northwest, that means that the change in temperature, at least in an instantaneous sense, should be this number here. Okay, as was already commented, but I just wanted to put it on the slide, we write the gradient of f, vertical bar, little subscript 0.34, and we write gradient of f and then of 0.34 interchangeably. So sorry for the sort of different notations, but you'll see a lot of that kind of thing in a third semester calculus class, right? So same deal as far as the directional derivative itself is concerned. You'll see sometimes a vertical bar with the point to evaluate at written in tiny like 6-point font kind of underneath, or you'll just see the standard 12-point font, the information for the point listed just in parentheses to the right of f.